Now that we have learned how to factor polynomials, we're going to start solving some things by factoring. And we're going to start by solving just equations by factoring. So we have a couple of definitions here. The first is a polynomial equation, and that is an equation with whose sides are both polynomials. So if we look here, this is a polynomial. This is technically a polynomial. 0 is a monomial, which a monomial is a type of polynomial. Okay, this is considered a linear equation because the highest exponent is 1. This is a quadratic equation because the highest exponent is 2. And usually when you have a trinomial, it'll be quadratic. This is considered to be a cubic equation because its highest exponent is 3. We can still solve these, but we're not going to graph them. This would graph as a straight line. This would graph as an exponential line. This one you don't even want to know. Okay, so standard form. One side of the equation is 0. Variables are in descending order of power. So if we look at this quadratic term, this is in standard, or quadratic equation. It's in standard form. Actually, all three of these are in standard form because they're all equal to 0, and the variables are in descending order of power. So my common variable here is x. It goes x to the second, x to the first. This is actually x to the 0, which is just 1. Here, it's equal to 0, x to the third, x squared, x to the 1, x. Okay, and this one's just x to the 1, x to the 0. Okay, so that is considered standard form. You want to put things in standard form just because it's good. So we have the multiplicative property of 0 can be stated as follows. If a is equal to 0 or b is equal to 0, then a times b is equal to 0. Okay, this is super important when solving equations, polynomial equations by factoring. Okay, if I can factor this whole side and I know that it's equal to 0, that tells me that any one of those factors could be equal to 0. Okay, and that's going to come into play a little bit later. All right, so the statement shown above, if a is equal to b or b is equal to, if a is equal to 0 or b is equal to 0, then a times b equals 0. So this is an if-then form. If a is equal to 0 or b is equal to 0, then ab is equal to 0. The converse of a statement in if-then form is obtained by interchanging the if and then parts of the statement. So basically that means I can change this around. If a times b is equal to 0, that means that a is equal to b or b is equal a is equal to 0 or b is equal to 0. This is the converse. Okay, so if I have a situation like this, then I can say, well, either one of these or both of these could be equal to 0. The converse of a true statement is not necessarily true, although this particular one is. So this particular converse is true. The words if and only if are used to combine a statement and its converse when both are true. So the zero product property stated below combines the multiplicative property of 0 and its converse. So in English, basically the zero product property says if a and b are real numbers and a times b can equal 0 if and only if a is equal to 0 or b is equal to 0 or both are equal to 0. So a product of factors is 0 if and only if one or more of the factors is 0. So that's kind of the whole crux of solving these polynomial equations. So the zero product property is true for any number of factors, and you can use this property to solve certain equations. Okay, so let's get to it. Example 1. Here I have a polynomial that has already been factored, and we know that it's equal to 0. So what that means is that this product or this factor could equal 0, or this factor could equal 0, or they both could equal 0. So here's how we solve for x. We could say, well, x plus 2 could possibly be 0. And in order for that to be true, x would have to equal negative 2, because negative 2 plus 2 is 0. X minus 5 could be equal to 0. And in order for that to be true, x has to be equal to positive 5, because positive 5 minus 5 is 0. So my solutions then are negative 2 and 5. Those are the two numbers that will make this equation true. And the way we got those two numbers is we just had this completely factored, and we set each factor to 0. okay, to make the equation true. So here again, we have another polynomial that has been completely factored. It has three factors. 5n is a factor, n minus 3 is a factor, and n minus 4 is a factor. We know that multiplying these three factors together gives us 0, which means that either one or all of these are equal to 0. So to solve for n, we set each one of them equal to 0. So if 5n is 0, that means that n has to be 0. If n minus 3 equals 0, that would mean that n would have to equal 3. And if n minus 4 equals 0, that would mean that n would have to equal 4. So my solution then is 0, 3, and 4. Those are the three possible solutions for n to make this equation true. Now, here's a clue. If I were to go back here and use FOIL and multiply this out, I would have a quadratic polynomial, meaning that the highest exponent would be 2. That exponent tells me there's two possible answers. Here's my two possible answers. If I were to multiply all of this together, n times n would give me n squared, times 5n would give me 5n cubed. That exponent of 3 tells me there's a possible 3 solutions, okay? So the highest exponent tells you how many possible solutions there's going to be. Sometimes you have two solutions that are the exact same number, okay? But it tells you how many they're to look for. So this tells me, since this is a quadratic equation, that there's going to be two solutions, okay? Those two solutions might be the same, but I need to look for them. Now, this is not in standard form. So before I factor anything, I have to put it in standard form. So 2x squared plus 5x minus 12 equals 0. Now I can factor this side. I don't see a greatest common factor. There's no, it's not a perfect square trinomial. So I'm going to use slide divide bottoms up. So x squared plus 5x minus 24 equals 0. And I'm going to write it out here, my x. So I want to add to get 5. I want to multiply to get negative 24. So this tells me one's positive and one's negative. So I'm looking for two factors of 24 whose difference is 5, and that's going to be 8 and 3. Since this is positive, my 8 will be positive, my 3 will be negative. Before I go any further, I check this. Negative 3 plus 8 is positive 5. Negative 3 times 8 is negative 24. So far, so good. So I'm going to write x minus 3, x plus 8 equals 0. But I've done my slide. Now I have to divide. I'm dividing by 2. And I'm going to do my bottoms up. So I have 2x minus 3. And this one simplifies to x plus 4. Okay, so now I've factored the whole thing. I put it in standard form, I factored it. Now I have to set each factor equal to 0. So if I have 2x minus 3 equals 0, 2x will equal 3, x will equal 3 halves. Notice it's the opposite of the number I had here. And here I'd have x plus 4 equals 0, so x is equal to negative 4. So when I have a coefficient in front of my quadratic term that's not 1, it tells me that I'm going to probably have a fraction as one of the solutions. So my solutions then are x equals 3 halves, and leave it as 3 halves. You don't have to make it into an improper or into a mixed number, and negative 4. All right, let's look at this one. We look at it and say, oh wait, it's already factored. Yeah, but it's not in standard form, which means that we have to use FOIL to unfactor this, and then we have to incorporate that 12. So if I use FOIL, I'm going to have x squared. This will be 3x minus 1x is 2x minus 3 equals 12. I incorporate that 12 by just subtracting it. So I get x squared plus 2x minus 15 equals 0. This one I can just do a regular x box. So I'm going to add to get 2, and I'm going to multiply to get negative 15, which means that one is positive, one is negative. My choices for 15 are 3 and 5. The difference between 3 and 5 is 2. This is positive, so I'm going to make my 5 positive, my 3 negative. I am going to check before I go any further. Negative 3 plus 5 is 2. Negative 3 times 5 is negative 15, so it worked. So I have x minus 3 and x plus 5 is equal to 0. So x minus 3 equals 0, so x would be 3. And x plus 5 equals 0, so x would be negative 5. So my solutions then are 3 and -5. Okay. So double check if it's not in standard form, you have to put it in standard form first. In this case, I had to undo the factoring, incorporate that 12, and then factor it again. All right, let's look at example 5. Okay, it's already in standard form, which is good. I look at it and I can automatically see that I'm going to have a greatest common factor. So let's take care of that first. Because this is a 3, that tells me there's going to be 3 possible solutions. So I think the greatest common factor is just going to be 2y. And I'm left with 9y squared plus 12y plus 4 equals 0. And this looks like it could be a perfect square trinomial. Square root of this is 3y. Square root of this is 2. 3y times 2 is 6y times 12 is 12y. So yes. So this is going to be written as 3y plus 2 squared. Now, because I'm looking for 3 factors, this right here tells me I'm going to have 2 of the factors that are going to be the exact same number. Okay, because this would just be 3y plus 2 times 3y plus 2, which will give you the same solution. So I have 2y is equal to 0. So y would equal 0, and 3y plus 2 equals 0. So 3y equals -2, y is equal to -2/3. So I have 0 and -2/3. And I recognize that this is actually 2 solutions. We call this a double root. Okay, I don't have to write it again because it's just the same number. But recognize I'm looking for 3, and I have this one just as a solution twice. Okay. Let's look at example 6. This one's fun. Write an equation in standard form whose solution is 2/3 -4. So basically, we're starting here and we want to work our way up here. Okay, so think about how we went from here to here. We're just going to do it backwards. Okay, so basically, they're telling us that our solutions are 2/3 and -4. So I can write 2 equations. I can say x is equal to 2/3 and x is equal to -1/4. From there, I can rewrite these so that it's an equation equal to 0. Well, x minus 2/3 is equal to 0, and broken lead, and x plus 4 is equal to 0. So these are my 2 factors, okay? So I had x minus 2/3, and I had x plus 4, okay? Well, x minus 2/3 is the same as 3x minus 2. Okay, think about this. If I had, let's do it this way. Let's go back. I'm looking for an eraser. Let's go back on this one. Let's multiply each side by 3. So I have 3x equals 2. And then we'll subtract. So I have 3x minus 2 equals 0. So that's going to give me 3x minus 2 here. I was doing it a different way, and I think this way is probably makes the most sense. Okay. So then we would say, okay, well, now all we have to do is multiply. So I have 3x times x is 3x squared. 3x times 4 is 12x. -2 times x is -2x. And -2 times 4 is -8. And I can combine my like terms. Okay. If I plug these in, it should work. If I plug in -4, -4 squared is 16, and 3 times 16 is 48. -4 times 10 is 40, so minus 40. And then minus 8 gives me 0. If I plug in 2/3, okay, 2/3 squared is going to be 4 divided by 9 times 3, plus it would be 20 divided by 3 minus 8, and that's going to give me 0 as well. Okay, so doing this, we're just going backwards. So you start off by setting each one, rearranging it so it's equal to 3. You want to get rid of the fraction though. Those are your factors. You just multiply through. Okay, let's solve. Now, here we have a situation where you want to say, well, let's divide each side by a. And we end up with a squared equals 4. And then the square root of 4 is 2. So you could say, well, a is equal to 2 or negative 2. But this 3 right here tells me that there should be 3 solutions. So I can't just divide by a. What I'm going to do is I'm going to take a cubed minus 4a is equal to 0. And then I'm going to factor out my a. So I'm not really getting rid of it. If I just divide both sides by a, I've gotten rid of it. Here I haven't gotten rid of it. I've just moved it out. I have that. Now I have the difference of two squares. And it's going to factor like this. So see how I have, except that that's not going to be a 3, it's going to be a 2. See how I now have my 3 factors? Okay, I have a is equal to 0, a minus 2 equals 0, and a plus 2 equals 0. So my solutions are 0, this would be 2, and this would be negative 2. 3 solutions. 0 is a solution. It's a number just like any other. If I divided both of these sides by a, I've lost that 0. I've lost one of my solutions. Okay, so even though it's tempting, you can't do it. Put it in standard form and then factor it. All right, this one's already factored for us. So we're just going to set each one equal to 0. So x equals 0, that was easy. 2x minus 5 equals 0. So 2x is equal to 5. X is equal to 5 halves. And here we have 2x plus 1 equals 0. So 2x is equal to negative 1, and x is equal to negative 1 half. So my solutions are 0, 5 halves, and negative 1 half. If I were to multiply all this out, I'd have a x cubed. 2x times 2x is 4x squared, times x is 4x cubed. So that's where I get the 3 solutions from.